Now it should be recording.
Yes, now it's recording.
Okay.
Thank you. So you can right click on my name and then make me a presenter. And my role. Okay, thank you.
You're welcome.
Okay. Before we start the section, I would like to give us a rundown. We have about 14 chapters in this particular course, which is the IT Essentials. And I want to see how it will go. After every chapter, I'm going to activate the assessment, and so that we can get the assessment done. I'm going to show us how you can assess each chapter exams, possibly if at the end of this class, so that if you have any challenges, you let me know. Because for every chapter we cover, you're meant to do a chapter exam. There's also a quiz that's available for us. So I'm going to start right away. As potential instructors, there's need for us to read ahead. And that is the reason why you enrolled into the program prior to the class, so that you can have access to the material, go through the content, and be sure you familiarize yourself with everything. However, once that is done, once you have sections like this, it becomes so easy. If you have questions to ask, then you can be going. So today we'll be looking at Introduction to Personal Computer Hardware. Looking at the personal computer, you're looking at the computer system itself, the components that exist inside the computer. So briefly, we're looking at the objectives. The objective here is to be able to explain how personal computer components safe, as how to keep personal computer components safe, be able to explain the components in the computer, explain electrical and ESD safety. The full meaning of ESD, electrostatic discharge. And then we'll be looking at PC components. Under the PC components, we'll look at how to explain the features and functions of the computer component. Please, can you hear me? Can we hear me, please?
Yes.
Oh, lovely. So we'll also look at how to describe cases as computer cases and power supply. We'll describe the motherboard, describe the CPU, explain types of memory. We'll also describe adapter cards and expansion slots, describe hard disk drives and SSD. So in summary, this chapter actually identifies a computer system, the different components that exist in the computer system, how they're interconnected, and then be able to identify their functions, and then be able to explain their mode of operations. So once you're able to explain each of these, and then think you're good. As instructors, we need to know this so that when we're teaching our students, we can explain better. And so we'll also describe optical storage devices, describe ports, cables, and adapters. We describe input devices and output devices. Now, all of these actually are there within the computer systems. Like we're talking right now, I want to believe you have your computer with you. When you look around your computer, you see some ports. Some of the ports are USB ports, some are VGA ports, some of the ports there are HDMI ports. So we're going to identify those ports and then other associated components. And then disassemble a PC and then explain the features and functions of each component in the toolkit. Disassemble a computer as well. So These aspects of disassembly and assembling the computer system will be done in the lab. What I would do for us is that there are simulators that can help us explain this better. So I'll see how I can find my way around that. And so, looking at the personal computer, we did say that we'll be talking about the electrical safety aspect of it. Every electronic system is driven by power, so power is important when it comes to system functionality. And so electrical devices have certain power requirements, and then we need to look at the requirement. AC adapters are manufactured for specific laptops. If you look at your laptop, the one you're using, you have an adapter, a power adapter. This power adapter actually rated in DC volts. We have two types of current. It's like DC current and AC current, direct current or on alternating current. But in this case, we're dealing with the AC adapter, which takes in the AC. But then within this box you can see here, you have what we call rectifiers. Those rectifiers are like diodes that are inside this box. They convert the AC current into DC current, because most of the components on the computer motherboard actually work with what we call DC current. And so when it comes to the laptop, the same thing. Your laptop actually takes in AC from the AC socket, and then you now have it converted to a DC. And so you have different ratings. So you're not expected to use different power adapters. Maybe the same power adapter for different laptops. Reason being that the power rating might not be the same. So when it comes to powering of computer systems, it is very important we work with a required current or voltage that is needed to drive that device. I do believe in Nigeria, some parts of West Africa, most of our desktop computers and laptops, desktop computers precisely, actually takes in 220 volts, 220 volts. But then in the US, I believe, and other parts of countries, they actually use 110 volts. So you can see here that if your power system is rated in 220 volts or 230 volts, the case may be, and then you put it on the 110 volts, actually that would damage the system. So it is good to understand how the electricity flows, and then what is the requirement for each component, and then be able to work with the different power ratings and voltage, or sometimes current. So we need to look at the current, which is measured in ampage. We look at the voltage, which is measured in volts, and all of that, and the power, which is measured in watts. So all those are requirements to be sure that there's some level of electrical safety. So some printer parts, such as power supply, contain high voltage. So you check the printer manual for the location of high voltage component and ensure that you adhere to such instructions. So what we're saying here invariably is that you're meant to actually look at the manual and be sure that you're working with the right standard. Okay. So we also said that ESD, looking at ESD safety. What is ESD? Electrostatic discharge. This can occur when there's a buildup of an electric charge, that a surface which comes in contact with another different charge surface. And so ESD can cause damage to computer components if not discharged properly. Our body systems are also made to understand that our body system can build like about 3,000 volts of static electricity, which can actually damage some of these components. So it is best that you use what we call strip, more or less, when you're doing the troubleshooting. The reason is just to be able to earth those trapped, ESD, that's the electrostatic discharge, to be able to discharge that whole static electricity from your body down to the earth, so you can earth it down to zero. This is very important because most of the components inside the computer motherboard actually can be damaged with bare hands because we have our body system that builds up static electricity. So we are advised to put on some strip and have some protective gases such to avoid this discharge of excess voltage from our body to the devices. So there are ways you have to do this to avoid damage. So we as instructors need to demonstrate this to our students, and so that they'll be able to know, take the right precaution in the computer lab. Okay, during troubleshooting. We'll talk about troubleshooting, we're talking about repairs. So in the course of repairs, those precautions are to be taken. So follow this recommendation to help prevent ESD. So what are the precautions to avoid ESD damage? One, you keep all components in anti-static bags until you are ready to install them. So all the components like your RAM, like your adapter card, sound card, all of that, the CPU are meant to actually be in anti-static bags to avoid damage. And then you use a ground mat on work benches. The ground mat is so as to avoid discharge of current, so that will help. That will create some kind of insulator to the circuit board. So it's good to use grounded mat on work benches. And then we use grounded floor mat in work areas. All this is to help to ground excess voltage. And then we use anti-static wrist straps, like I was saying, when working inside the computer, so that you're not expected to use your bare hand to work inside the computer system. So these are some of the precautions that we have to take as instructors so that our students will know the right thing to do all the time. Okay, so we'll quickly look at the PC component. Here, the case houses the internal components such as the power supply. So when we talk about cases, we're talking about computer cases. So you can see here that we have different types of cases. We have the tower type, we have the horizontal case, we have the compact tower type, we have the all-in-one. And so what we're saying invariably is all these are called computer cases. And what they do, they house the component. They house the computer component. So the case houses internal components such as power supply, in the case of the desktop, motherboard, central processing unit, which is the CPU, memory, including a RAM, disk drive, storage, and associated adapter. So it is called a computer case or a system case. Some of our students sometimes refer to it as CPU. So it would be wrong to address as a CPU because it is actually a computer case. The box can be empty. And so the CPU is also a component inside the computer case. So hence, we should note that these are computer cases and they come in different form factors. When we talk about form factors, we're saying they come in different shape and sizes, okay? So the term form factor, just like I just earlier mentioned, refers to the physical design and look of a case. So common desktop computers are available in the form factors, which include the horizontal type, full size, compact size, all in one. So this has to do with the different shapes and sizes of the. So I can ask you what kind of computer, what kind of form factor do your computer case is, so you can be able to explain to me. You say, oh, I'm using the horizontal case type, I'm using the full size tower type. So what we're saying is that because they come in different shapes and sizes, the right word to use to describe them is the form factor. Okay. And then we'll talk about the power supplies. It would be nice for us to understand that those power supplies come in different factors they have. So we need to know that here today. Computer uses a power supply to convert AC power into a low voltage, which is DC power required by internal components. These I've explained earlier that this power pack actually takes in the AC and converts it to a DC. And you can see at the other end here, there are some cables. These cables here are meant to actually to be connected to some of the components, like the board, as a computer motherboard. We also have the one that will power the fan, the CPU fan, and all of that. So what you have coming out here at the different ends of this cable, they actually rated in DC volt. So what goes in AC and what comes out is DC. And then if you look down here, you see a red button. This red button is actually a switch that you can switch between 220 and 110 volts. So if in your area you use 220 volts, you're meant to preset this to 220. And if you're using 110 volts, you maintain it at 110 volts. We've had cases where technicians have actually messed up with systems, or because they didn't take proper precaution in checking the power switch. So you need to check and then be able to adjust it to suit your power system in your country. Okay. And so the desktop computer power supply form factors include, so like we talked about the form factor, so we have different power supply form factor. So we have what we call the advanced technology, which is the AT, and the original power supply for legacy computer systems. So we're talking about previous computer systems we have actually has been driven by the advanced technology, the AT power system. And now, updated version of the AT, which is what currently also in vogue, is that you have the AT extended, is an update of this one. And so these are different power supply forms to drive different computer systems. So we also have the ATX and 12 volt. The most common power supply on the market today is the ATX 12 volt, which is still the advanced technology extension 12 volt. So this actually takes in 12 volts, and that is actually what we have currently, which is common. And then we have the EPS 12 volts, originally designed for network servers. This is for enterprise servers, precisely. So the power system for enterprise servers are quite different from what you use for your normal desktop. Remember, when you're talking about computer and servers, they're actually quite robust and they are used for high-end activities. So they have a special power supply form factor, which is the EPS 12 volts. Okay. So a supply includes several different connectors. If you recall earlier, I did say this is the power pack, and it has different cables that are used to power different components in the computer motherboard. So here, the power supply includes several different connectors. So we have different connectors, so you can see them with different form factors. They all have different components they are meant to power. And so it's your responsibility as an instructor to be able to identify the different connectors and make sure they're actually placed in the right port. So a power supply includes several different connectors. They are used to power various internal components, such as the motherboard and disk drive, which is your hard drive. Some examples are, we have the 20-pin or 24-pin slotted connector. And so you can see here with this one, and this is the one that actually goes in straight to the motherboard. You know, the motherboard itself is a circuit board in which the circuit board housed all the internal components. And so what the cable you use to power it is this. And on the computer motherboard, there's a slot. There's a particular slot for it. And so you could see the number of pins, and then you put it to the corresponding port. And so the good thing about this is that for every connector, there's a port for that connector, and it goes with the pin configuration. So you will first of all let the student understand that how many pins are there for this particular connector. They will tell you, oh, in this case it's 20, in this case it's 4. And then right there on the motherboard, the pin configurations also, the slot also will tell which connector is meant to be connected to it. So you as instructors will have to identify that and then makes it not easier. So I also try to see how I can get a motherboard so I can show us live so that we can be able to identify the different ports as well. But however, the picture actually demonstrates this, and so it will make it easier for us to identify them. So we said, and then also we have what we call the SATA keyed connector. So when we talk about the SATA keyed connector, this comes in two forms. You have the SATA data cable, and you have the one for power. And so the one for data actually has a port where you have to connect it, and then the one for power actually same thing. So in this case, you have to use the right one. So and each of them has its own pin configuration. So we also have what we call the Molex keyed connector. And then we have the third keyed connector, we have the 4-pin, 8-pin auxiliary power connector, we have the 6x8-pin peripheral express power connectors. So all these connectors are here, and then we are saying that it is nice that we take each of them. For instance, this is the SATA, the one next to the 20-pin is SATA, and then we have the Molex. The Molex is here, and then we have the Bird, and then we have a 4-pin. So all are here, and the reason is just for us to be able to identify them and then show them to our students and say, okay, this connector is meant for this is meant for that, and all of that. And then demonstrate to them where that's connected. So the next time they pick up that particular connector, they know the name for it. Okay, so power supply voltage. The different connectors in the power supply also provide different voltages. Okay, like I said earlier. So you have different connectors supplying different voltages to drive different components. Not all components on the computer motherboard takes in the same volt. So the most common voltages that are supplied are 3.3 volts, 5 volts, and 12 volts. So what we're saying is that this is the common voltages that drive the various internal components on the motherboard. So, for instance, you have a USB port. The USB port takes a particular amount of voltage, most cases 5 volts, DC volts. And so when you plug an external device to it, what we're saying is that it will just take the normal 5 volts and then be able to power the device. So the 3.3 volt and 5 volt supplies are typically used by digital circuits, while the 12 volt supply is used to run motors in disk drives and fans. So it's been specified here what the 12 volt is able to use to power, and then what the 3.5 and 5 volt are used for. So we particularly now know that when you want to power your hard drive, you need some high amount of voltage, which is about 12 volts. Okay, so the power supply can also be single rail, be dual rail, or it could be multi rail. So these are like different pattern of power supply. Okay, so a rail is a printed circuit board inside the power supply to which the external cables are connected. So the rail are more or less like a bus line, the part in which the power signals actually passes through. And so what we're saying is that it could be of different form. It could be that which is double, it could be single, it could be multi-rail. So these are the pathways that the power signals will pass through. So in a typical computer system, you have data signals, you have your power signals, and then you have a control signals. And all these signals will have to pass through some kind of pathway. So we are saying that it could be single, it could be dual, and it could be multi real or multi-path. Okay, so you can see the printed part of it. It tells you that these are like lines, these tiny lines you're seeing. These are pathways that drives your data signals and your power signals. Okay, so the motherboard is backbone of the computer. Without a computer motherboard, there's no computer. It is a printed circuit board that contains your buses. When we say buses, we're talking about the pathways, like I said, or electrical pathways that interconnect electronic components. So they help. So you can see those tiny wire, those tiny lines you're seeing here. They are the part in which that helps to take the signals and then power those devices. So these components may be soldered directly to the motherboard or added using sockets, expansion slots, and ports. And so we have special slot. This is just the backside of the motherboard. The front side we have, like you can see here, we have a port where you have the associated components be connected to. So here, this is the back side of the motherboard, and this is the front side where you have all your components. So the major components on a motherboard include the central processing unit, and here is the CPU. So this is the CPU. The CPU you see here is actually the brain of the computer. The CPU actually takes in your taking your data, decode your data, and execute. So it does processing of data and all of that. So it actually also depends. It also helps to determine the speed of the computer. It's one very vital component which our students must know. And inside this computer, one very CPU, we have hello. Can we mute? Hello. We have hello. Can we hear me, please? Hello.
Yes, please.
Okay, please. We have two different devices connected. It might actually echo, so it will be nice to. Hello. Hello. Hello.
Hello.
Can you hear me?
Yes, we can.
Okay. Okay. Thank you.
Yes, you can mute, except if you have a question or something.
Yeah, I was just hearing noise coming from somebody, so it's just a question or something. Okay, so can I go ahead, please?
Yes, please.
So at the end of the section, you can ask questions when necessary. We're talking about the internal component that is on the computer motherboard. And I said it is important that we actually get a live motherboard to demonstrate and explain or identify each component and make our students understand what they stand for, what they do, and their mode of operations. That helps the student to have a clear cut of the behavior of the computer system. And so I was actually talking about the first component, which is the central processing unit, and I said is the brain of the computer. This is where most of the activities actually takes place. This is the part of the computer where information are fetched, information are decoded, and then executed. And so it's just like a student in the class who can solve problems, and other students have to come to that student and say, please, can you solve this mathematical problem for us? And the student keeps solving and solving. So you can imagine if everybody's meant to come with their different problems for this sharp chap to be able to solve. I mean, normally what he would do is to keep them, tell them to actually keep them somewhere where he picks them one after the other to solve, and that place where those problems need to be kept is like what we refer to as the memory. And so the CPU does that. So the CPU fetch information. So the modern day CPU have memories inside them, which we refer to as cache memory. And so that cache memory is where you have some information are fetched and kept, and then when they are decoded, executed, more information will be fetched. With the legacy CPU we used to have, most of the memories are external, so the processor will actually have to go out from its domain, fetch information from an external memory, decode them, and then execute. But with a modern processor, you already have memories within them, which we call cache memories. And so there's a link between the cache memories and the external memory. So all the tasks and all the activities that we carry out on our computer on a daily basis are actually stored in the external memory. And from the external memory, they are connected through what we call pipeline. There's a pipeline, in other words, the bus wires connection to the CPU. And then they go into the cache memories, which are arranged in L1, L2, L3 series. Now, the L1, L2 series is just to tell you the different cache memory levels. And that is where the CPU fetch this information and decode and execute them. And that's the reason why most of the modern computers we have today are quite fast compared to the legacy kind of computer. So the CPU also contains transistors, and these transistors, the number of transistors you have inside the CPU determine the speed of the CPU. So I'm saying all this because we need to know how powerful the CPU is. And so that is why you can say, oh, this CPU is dual core, this is I-core 3, this is for i7 or for i5. And so the higher the number of transistor budget, the faster the CPU, and the more expensive the system. So in most cases, the capacity of the CPU also determines the cost of the computer itself. Okay. So we have the random access memory, which is the RAM, and you can see here the RAM slot. So we have a RAM being inserted in the RAM slot. So you can see some. You can see the shape here. So you need to get the right form factor, the right RAM form factor to be slotted here. Okay, and so expansion slot. Expansion slots, you can see them here. You can see what we call expansion slots. These are actually slots that are made available should there's need for you to add new components or adapters. You can actually put them, insert them here. So they are expansion slots. They are made available for more devices to be added. And then the chipset. So you can see the chipset here. Look at the chipset. This angle here. The chipset is actually where that more or less like connection with the firmware, where you have most of your chips that help control the behavior of the system. And then you will have the basic input-output system, which is the BIOS. Here, you can see the BIOS here, chip here, and United Extension Firmware interface chip. So here, for the BIOS and the UEFI, controls the basic input-output system. In other words, control the call, the post, the power on circuit. From the time you power on the system, to the time when the post is completed, we're saying that this BIOS helps you to achieve that. And then it contains all your setup. For instance, you want to do anything, you can actually interrupt the process. So it's already pre-configured. So these are instruction sets that are already written into this component by the manufacturer to tell the computer system how it's boot, has been boot, and until when all the instructions goes through the normal procedure of testing the different peripheral devices if they are connected. It also helps you check if your fan, the CPU fan, is connected well. Sometimes when the post is not completed, you can see sometimes it's giving you some sound, maybe a beep sound, and then that tells you that, oh, maybe your RAM is not well fitted. Sometimes tells you the CPU fan not working. Now that is the instructions already written into the BIOS. So we are saying here that it's important that we know this and know what the function is. It helps our students to be able to explain that better. And then SATA connectors. I mentioned SATA. This is the full name of SATA, is Serial Advanced Technology Attachment. This actually is the modern connectors we have now. Prior to this period, the legacy one is the IDE cable, where you have about 40 pins. But today, we have them as SATA. Like I said, they come in the form of data, as data SATA cable or power SATA cable. So you need to know the right one to use. And then we have the internal USB connector for connection. So you need to have some USB devices that are also connected. So that's what we have there. Okay. So I've explained the chipset also. It consists of integrated circuits on the motherboard that controls how system hardware interact with the CPU and the motherboard. So that's what the chipset does. And most chipset consist of the following. They consist of two types. Remember we said it helps to control how the system, the hardware interacts with the CPU. And the hardware we're talking about here is like your RAM, your expansion slot, USB ports and all of that, your RAM, your video card. So the chipset helps to create that interactivity between the CPU and the device. And it's further divided into two, the north bridge and the south bridge. The north bridge controls high-speed access to the RAM and video card, while the south bridge is where you have, it helps to connect the CPU to communicate with lower speed devices such as USB port and function. So that is what the two does here. So the north bridge you can see from the RAM and the video card perspective, and even the CPU is on the CPU is on the south bridge. But what we're saying here is that your RAM and video card, the north bridge side, and then your CPU and your port. So in other words, the south bridge controls all the verifier devices, which include your USB port, your VGA port, and all of that. So you can see from the diagram here the position of the south bridge. You can see the position of the north bridge, and you can see the CPU. So the CPU is the brain that connects both the north bridge and the south bridge. But the north bridge has its own connection to the RAM, and then to the adapter, the PCI Express graphics card adapter. And then you can see here that your south bridge is the USB connectors and all of that, which you use to connect your keyboard, you use to connect your hard drives, maybe in case of SATA. So what we're saying here is that with this architecture, you'll be able to explain to your student the behavior, the mode of operations of the internal component of the motherboard. I mean, actually, it summarizes everything here. So you can let them know that this is categorized into north and south bridge. And then you let them know the components that are connected to each of those bridges. Okay. So we'll talk about the motherboard form factors that I've explained earlier. So here we can see them in ATX. You see the description, advanced technology extension, and then we have the micro ATX for some smaller computers, like all those mini computers. They use the micro ATX, and then the mini ITX. So depending on the size of the power system or the form factor of the power device, that determine which of the form factors to use. So what we're saying here in every is that not every computer system uses the same power supply technology. So you have to check to see which category, either the ATX or the micro ATX or the mini ATX. And then here the description of each of them has been stated in terms of their dimension, in terms of their shape, just to let you know which can be categorized under different categories are specified here. So the choice of the motherboard form factor determines how individual components attach to it. Okay, so the type of power supply required and the shape of the computer case, like we said earlier. So we have actually talked about the CPU, and here we have more information for the CPU. The CPU, like I said, is the central processing unit responsible for interacting and executing commands. The CPU is also a small microchip that resides within the CPU package. You can see a typical picture of the CPU here, and then this is the package here. This is a slot for the CPU. Okay, so the CPU socket is the connection between the motherboard and the processor. So you can see it here. This is the CPU socket. The modern CPU socket and processor packages are actually built in the following architecture. So we have the pin grid array. The pin are on the underside of the CPU process package and is inserted into the motherboard CPU socket. While the LAN grid array, the pins are in the socket instead of the processor. So what we're saying here is that we have two types. One of them seems to be like more or less legacy use because this is the one that has its pin, and then the other type is the one that the pin is already there. All you just need to do is to, so it comes more or less like pre-configured with the motherboard. So whichever one you have, what we're saying is that it could be in different form, but their rating remains the same. The rating of a PCL of the CPU is in hertz. So you could have it like 1000 hertz, which is like 1 kilohertz, and you can have 1 kilohertz, 2 kilohertz, 2.5, 2.3, depending on the size of the CPU. So it comes in different specifications. So, but then whichever specification it is, the higher, the faster. So the cooling system, you can see the cooling system here. What the cooling system does is it helps to actually absorb heat from the CPU. So the CPU can heat up to a very high temperature. So what we're saying is that what will help reduce the heating effect is the aluminum heatsink, which actually you can see inside the motherboard. And then we also have the fan, which helps to blow the heat away from the heatsink. So these are types of memory we have. We have the ROM, and then we have the random access memory, which is RAM. So, but all memory chips store data in the form of byte. Be it the ROM, be it the RAM. But information that are in the ROM are actually written by the manufacturer, so they are actually programmed. So these are pre-programmed instructions from the manufacturer that tells how the systems will operate. And then the random access memory is more or less like the day-to-day memory used. So from when you plug in peripheral devices to your system, they use RAM memory. And then the RAM memory also is used in the course of activities on the system, like when you browse on the internet, or when you type in MS Word, Excel. So these are running activities. And so information in the RAM can easily be lost. So they are volatile, as you can see here. So RAM is volatile, and it can easily lose its information. So when you bring anything in the system, you're actually using the RAM. It's advisable that you save to your hard disk. So adding more RAM in the computer enhances the system performance. So the higher the RAM, so the RAM is more or less like the food of the computer, because without the RAM, the system seems to have limited space of operation. So you need to look at the best way to upgrade the system RAM. And of course, there are limitations to the upgrade depending on the capacity of the system. Okay. So these are the different types of RAM. We have the ROM chips. We have the programmable ROM. We have the erasable programming ROM. We have the EEPROM. Please, all these is just tell a different form of ROM. Remember, I told us that ROM are instructions that are bound to the drive to guide the systems on how to boot and load up your operating system. So they are more or less like the device that houses your middleware. So types of random access memory, which include dynamic RAM, static RAM, synchronized dynamic RAM. So these are different types of RAM, and all these RAM actually are used for different, depending on the system, the form factor of the system, and then depending on which requirements. So we have all these specified for different computer systems. So it all depends on that which is manufactured with. But then each of these means a lot. For instance, if you're using the static RAM or somebody using the DDR RAM, the static RAM is not as terms of speed or performance, but invariably it's used for different computer systems. So you need to be very sure the requirement for you. So you can see whether your system is meant to use static or meant to use the DRAM. So memory modules. So memory chips are actually sold at the circuit board to create a memory module which is placed into a memory slot on the motherboard. So there are different types of memory modules. The deep, it could be the SIM, it could be the D memory, and it could be the SODI. Now, each of these types of memory, each of these memory actually is used for different. For instance, let me just say, like the SODI is being used for, like printers, they use SODI as a single online dual inline memory module. So these are actually different types of memory that are used for different type of devices, cut across your printer, cut across your laptop, cut across your desktop computer. And so we must know the right one that is meant to be used for our system. Even some of the mini laptops, all the laptops you have actually, the memory there is referred to as SODI. So it just has to do with the form factor. So they are all memory which help to store data, but then they come in different shapes and depending on the system. That's the reason why you have a small system, and then you see that once you open it up, the memory there is different from the one you could see in your desktop. So they come in different shapes inside. So I was explaining to us the memory inside the CPU. So here we're looking at memory modules. So the three most common types of cache memory that exist. The L1 cache is integrated into the CPU. I explained it earlier that the CPU has all of this memory, and the SS is to fetch information from external memory and store them in three. For instance, once what is in one is executed, whatever information is in 2 will be emptied in 1, and whatever is in 3 is emptied into 2. And then from the external memory, it comes back to L3. So you can see that whole flow, I said, is referred to as the pipeline, a way of routing and receiving information from the external memory to CPU or process. Okay. So as a cache memory for you there. And then here, memory errors occurs when the data is not stored correctly in the memory chips. So the computer uses different methods to direct and correct data error in memory. Like I said, when they're not properly saved, it will lead to some error. So different types of error checking methods include non-priority. Non-priority memory does not check errors. That means once there's an error, it's only when you open up that file or thing that you see the error. And the priority memory contains 8 bits for data and 1 bit for error checking. So if it's the priority type of memory, what we're saying here is it has one of the bits that helps check in for error. And then the error correction code memory can detect multiple bit errors in memory and correct single bit errors in memory. So these are different memory modules, and this is how they function. And the essence of all this is just to either you're correcting error or you're ignoring this error, or it's at every point in time using one of the its bits as a place of priority to check for error. And if you're using the one that is non-priority and does not check error, it means that you have loads and loads of error in some cases. Okay. So here is the adapter card. Like I said, the data card actually you can slot them in the expansion slot. And so common adapter card includes sound card, network interface card, wireless NIC, video, display capture card, TV donor card. Now all these cards can actually be inserted in the expansion slot. So adapter card increase the functionality of the computer by adding controls for specific device. For instance, if your desktop USB port is bad, you can get an adapter that has more USB ports. So once you put that adapter, it starts inside the expansion slot. It gives you more USB ports to work with. So what we're saying is a room for compatibility. So you can always bring in new adapter and then plug into the system, and those ports will work. So common expansion slots that we have include the peripheral computer type, which is a PCI. We have the mini PCI, the PCI extended. So these are different expansion slots which we have inside the computer motherboard. And the essence, like I said, is to give room for more devices to be connected. Okay. So types of storage devices. So here we can see storage devices. Here, data drives provide non-volatile storage of data. So here, whatever you save in the data drive is saved. Not easily be lost. Example, which is some drives have fixed media, and other drives have removable media. So it all depends on the type. So the storage type we have, you can see from here, we have a hard drive, we have the optical drive. So here you can get some CD and burn some of the data, save them. We have solid state drive, which is smaller but compacted. And then you have the tape drive. So these are different types of storage devices. Okay, so storage device interfaces. So storage devices inside a computer connect to the motherboard using serial AT. I've explained the AT technology, which is the power supply type. Attachment, which is SATA connections. Legacy interface is the parallel ATA, which is what we're using before now. But now we've moved to the era of SATA, which is very, very common. So either you're talking about the ID or the parallel, sometimes we call it the PATA. So PATA means parallel adapter technology attachment. And so that's the legacy type. That's the one with the 40 pins rated for desktops. And then we have the current one, which is serial. And these come in different form factors as well. So this is still on the components. So here you're looking at magnetic media storage. As your hard drive has some metallic, it's actually a non-metallic magnetized physical areas of the magnetic media. And that's why if you look at your hard drive, it spins so it goes in that rotation form. So what we're saying here is that the hard disk, which is the traditional magnetic disk device with storage capacity, which is rated in gigabyte up to terabyte and all of that. And so it actually has that magnetic media type, which helps it to keep your information in different memory locations, and then be able to call them up when necessary. So here is a display of the internal structure or the internal architecture of your normal hard drive. So here is the SSD solid state drive. Like I said, it's small, but then takes in more data as well. So you can see the shape size. All this is just for you to save your data. Okay. So still on data. So we have a non-volatile memory express. This question was developed specifically to allow computers to take greater advantage of the features of SSDs by providing a standard interface between your SSD and the peripheral, the peripheral computer interface bus and the operating system. So these actually come in another form, still in a more compacted form. Most of our systems today, laptops today, they work. They are on SSD, which is solid state and drive. So what we're saying is that it's also in the form of non-volatile memory express. So they are smaller and smarter. They take more information. They are faster than normal HDD, but less expensive than an SSD. So we're looking at here the hybrid of the two. So I think everybody wants to go for the hybrid. So they combine the magnetic type on the onboard. So we're looking at the hybrid of both the SSD and the normal hard drive. Okay. So this is the optical storage drive where you plug in your DVD discs and then you store your information. The optical drives are removable media storage. As you can see here, you can actually put your DVD drive here. Sorry, your disc, your disc here, your DVD disc here, and then once you copied or once you save or burn any file, you can also retrieve that information. So types of optical storage. So you can see why optical, because it works with light. Very important. Okay. So we have the video ports and cables. Here we can see the different types of video ports and cables. The DVI for uses for printers, different types of digital visual interface. These video ports are cables that you can use to actually connect for display. So a video port connects a monitor to a computer using a cable. So we have different types. So if you look at your projector, it has the DVI cable. It also has the HDMI cable. Some even have the VGA cable. So what we're saying is that each of these cables actually meant to be used to display video. In other words, display graphics on the screen for us to see. So it all depends on the type that's available for you to use. The DVI is digital visual interface. And then the HDMI, which is a high definition multimedia interface, which is actually more refined. So the kind of graphics you get here are more better compared to what we used to have prior to this period. And the Thunderbolt 1 or 2. So Thunderbolt, you can see Thunderbolt that you also use to, if you look at your external drive, it also uses Thunderbolt connected type. So these are the different types of connectors that I use to display. So if you look at your projector, some of these modern projectors, they come with this Thunderbolt. So you have different types. You have for 1, you have for 2, you have for different purposes. Like this one you're seeing here for 3, actually is the one used for your external drive to connect to your system. So other ports and cables that are available are like your mouse, your audio, network port, photo port, IDE, and USB. These are ports that are available on the computer system. So we need to note this and then show them to our students. And so you can actually have converters. So these days, we discover that we begin to have systems that don't have HDMI So how do you get an HDMI working on that system? So we have converters. So what we're showing us here now under the example of adapters is different converter types. So you can actually have the one that is of Molex, and then you can convert it to SATA. So that there will be this backward and forward compatibility. So for that backward compatibility and forward compatibility, there's a need for the different connectors or different video ports to be able to be converted to what you have. So if, for instance, you have a VGA port and then you have a projector that uses HDMI, you can get a converter that will convert it from the normal DVI port or VGA port to the HDMI port. So here we have the original input devices. Remember, I was talking about devices that are inputs, that are outputs. So some of the first input devices actually include the keyboard, the mouse. These are all input devices. So when you talk about your output devices, you're looking at your monitor, you're looking at anything that actually display information is your output. Okay? And so these are different output inputs. So I would love us to add these different types to what we already know about input and output devices. Okay? So this is still an example. Okay, so here we have virtual reality using computer technology to create a simulated three-dimensional environment. So once you wear it, you can see what the guy is wearing at the right hand side. You know, that will create a kind of virtual reality. You know, I think Cisco is already working on this to see how students can learn using this, because some students like it when it's like a simulation. So that will make them learn faster. So there are a lot of technologies that have been coming along around this virtual reality, which will help students to learn better and smarter. So a VR headset completely encases the upper portion of users' face, not allowing in any ambient light from their surroundings. So it makes everything, controls the external light around. Okay. So these are printers also. So these printers also can be an output also. Output devices that create hard copies of files. So when you send to them in form of input, and when they display, they are also output. So we need to have a clear distinction between output and input devices. So some of the output devices as well. And then here we're talking about how you can computer disassembly. It's one thing to have a system, it's another thing also to disassemble the system and probably to diagnose some advanced faults. And the other thing is like what you have assembled, you need to be able to assemble them. Okay, so we'll look at the procedure for this. So first of all is to power off and disconnect the power supply. So the first thing is that once you have your desktop computer, you need to power off. You don't need to be on when you start owning it and offing. That will damage the motherboard. So you need to power off and disconnect the power supply so that you know exactly where the things are coming from. And then once you power it off, then you now be able to begin to access the internal component. If you don't disassemble and it's on and then you're dipping your hand, you can damage more components. So remove the case screw, remove the SATA power data cables, remove the hard drive, remove the optical drive, remove the data. Once you remove all these, it gives you access to the main circuit board. Okay. So in the lab, we expected our students to be able to disassemble this. I mean, you as an instructor will pick up a desktop, you know, you unscrew the different components there, and then you bring them out. And basically, these are the things you're going to do here. Like we said, once you remove each of these, it gives you access to be able to access the circuit board. Okay, so you need to, like I said here, you need to remove the case screws using the right set of screwdrivers. You need to remove the setup data cables. All these are procedures to follow. Once you follow these procedures, then you can bring out all the components, demonstrate them to your students, show them like we just demonstrated here, and what they do. So once that is done, that has been disassembled. The next thing is you have disassembled something. I would advise that when you are disassembling this component, you make sure you look at them critically to know their different positions. Also make the student understand that they need to take their time to understand which screws is meant to be on a particular point so that you don't end up mixing them up. So when you remove the screws, you arrange them in that order that will enable you to be able to fix them back where they have been removed from. And once you do that, you can now be able to separate each internal component. And then, like we said, you must maintain that whole safety procedure. So you don't use your bare hands to hold these devices. This you must adhere to as instructors. We shouldn't just be with our hands and be holding this component. You might not help them because these students are going to grow up in the future and do the same thing. So we want to see how we can pass the right instruction to them. So once you disassemble this, you can be able to now take this component and show them, so they can feel it. You can explain what they do and then bring them back again, and then assemble them in the system, and then power on the system for them to see how it works. I think that will make your students to appreciate this course very well when you make it practical oriented for them. So, but then, like I said, in the next class, I'll try to see if I can get my hands on a live computer motherboard and show some of these things. It makes it easy. So here's a summary of what we hope to learn. And like I said, this is the objective. As an instructor, when you teach your students, you always let them know that there are milestones, and the milestones are the objective. So to ensure that you have followed the procedure and you have met the criteria to be sure that this whole procedure for learning has been followed, because they are meant to ask questions. So like here, we said explain how to keep personal computer safe, looking at the electrical part of it, explain components in the computer. You need to explain the component for them to know what they do, what each of them represent. You need to explain electrical and ESD safety procedure. They know what to do. So these are all the milestones for this chapter 1. So it's clear that after this explanation, you as a student go back again, read the entire content for chapter 1, and then try to do the assessment. You can do this assessment as many times as possible. The aim of this is for you to be able to know it, because you need to read over and over, know it, and then be able to teach your students so they can appreciate what the class is about, and then be able to apply it where necessary. So far, so good. Any question on chapter 1? I'd like to entertain a question now, and so that we can have the remaining 10 minutes to entertain questions. And let's make it interactive. Be free. If you have anything also to talk about, you can add it up. I was told that some of us have done this course before. So for some of us, it's more or less like a retooling section. Some of us is actually new. It's being recorded, so the recording will be available for you to play over and over while you go through the content online, and then prepare yourself for the assessment. So I'm going to activate the assessment at the end of this class, and hopefully you're expected to attempt them before the next class so that we can see how you're doing, find it interesting, and also please feel free to ask questions now. Hello, are we there?
Yes.
Okay,
guys, if you have any question, just unmute yourself and ask the question.
Yeah, I want to ask a question.
Oh, thank you very much.
Hello?
Okay, go ahead.
Yeah, my question is, the desktop computer, can you hear me?
Yeah, go ahead, please.
Yeah, the desktop computer, the power box,
Okay.
when it blows, can you work on it or you need to change it to? Yeah,
Sorry, can you come again? I think I lost you somehow.
this is exactly what I'm saying. As it blows, can you work on it or you need to change it totally?
Okay, once the power for a desktop blows, if you have to work on it or you change it totally.
Yeah.
Okay, I think from experience, if you know you have access to the right component, maybe around, you have an electronic shop where they sell those components and they are off specification. And sure, you can change the component and it will work. And one of the ways you can ascertain today is that you can actually check the output to see that it gives you the right voltage. And that's what we call a power regression test. The power regression test is where you on and off the device to be sure that it's giving you the right output. If the component the faulty component, for instance, that is unchanged, is not compatible with the one that was there before, you're going to have issues, and that will actually lead to maybe surge. And when you have high voltage going to the system, it might destroy the system. So, from experience, I think if those components are readily available and they are good quality, beautiful, you can change them and it will work again, and that will help you to save cost. In most cases, if you know you're not too sure of the replacement, then I advise you get a new one. Any contribution to that? If you have a contribution, you can also add. But that's my own experience. Sometimes if you open the power pack just to add more information, you see some of them you just have a fuse, a small fuse there with a tiny wire, and the fuse might just be 6 amperes. Some cases maybe 3.5 amperes. So if there is a surge probably on the electrical line, the fuse might just cut off. That's safety. You can also get another fuse of the same ampage, put it there, and then your power pack is back again. So you discover that the cost of getting a fuse might be very small, not too expensive. So you can actually repair the power pack. But like I said, make sure you get the right component with the right specification, so that you don't change the default setting. That might damage the system. Jacobo, are you okay? Hello?
Yeah, hello?
Yeah, Adams.
Yeah, I'm okay.
Okay, thank you very much.
Okay.
Any other question?
Oh, you know about
So how do we find this section?
I think unplug about class so our man will get my kind of call it. If I plug over Cisco could have so our man will get my new.
Hello? Okay. So I think in the absence of any question, we can end the section for today. This is the first class, so that we now need to go through the material. So Marilyn, I'm going to activate the assessment so that the student can start attempting.
Thank you. So guys, Dr. Daniel will share with us the recording and will activate the assessment. Please follow the first session, first chapter in the MetaCAD training, and then do the assessment as many times as you want for the chapter 1. Okay?
Yeah, that's good. Thank you so much. So I'm going to make the recording available. Yes, yeah.
Many thanks, Dr. Bennett.
Yeah, thank you, man. So the other folks, are they going to join us in the next class? I can see we have just 3 persons. Sorry, 5. Suleiman is not here.
Yeah, hopefully next session more of the teachers will be able to attend. Today they probably had problems to connect.
Okay. Thank you so much, Mary. Thank you all. Thank you, Abdul Adams. Thank you, Maru. Thank you, Seidu. Yakubu. You're welcome. And have a wonderful night.
Same to you, sir.
Yeah, bye.
Bye.
Yeah.
Hello, Marilyn.